Rocket Lab, Past, Present and Future. Introduction. Rocket Lab has established itself as a leading figure in the aerospace industry, providing launch services and developing advanced spacecraft technologies. Its evolution reflects a history rich with innovation, a robust present characterized by operational excellence, and a future teeming with ambitious plans. This report explores Rocket Lab's journey through its past milestones, current capabilities, and future aspirations. Past, historical milestones. The foundations of U.S. rocket propulsion technology were laid by the Air Force Research Laboratory AFRL, initially known as the AF Rocket Propulsion Laboratory. In 1950, the laboratory began its work on the XLR-87 engine, which was later developed into the LR-87 for the Titan Intercontinental Ballistic Missile ICBM. This advancement marked a significant leap in missile technology, culminating in the Titan ICBM's operational deployment in 1963. Rocket Lab itself was founded in 2006, focusing on small satellite launches with its Electron rocket. Designed for reliability and cost-effectiveness, the Electron rocket quickly became the second most frequently launched rocket in the U.S. Its inaugural launch occurred in 2017, successfully deploying multiple satellites for various clients, including notable missions for NASA and the U.S. Department of Defense. Present, current operations and technologies. Today, AFRL is dedicated to transitioning advanced rocket technologies into commercial applications through public-private partnerships (PPPs) programs such as the Integrated Powerhead Demonstration (IPD) and Upper Stage Engine Technology USAT aim to modernize U.S. upper stage engines and enhance modeling tools, which are critical for next-generation rocket development. The Hydrocarbon Boost Demo HCB program focuses on creating high-performance reusable rocket engines, reducing dependence on foreign technology. Rocket Lab has expanded its operational scope beyond small launches, currently developing the Neutron rocket to accommodate larger payloads and more complex missions. The company operates several launch sites, including Launch Complex 2 in Virginia, and has integrated advanced satellite systems into its offerings. Rocket Lab's spacecraft technology has supported over 1,700 missions worldwide, underscoring its growing influence in the space sector. Future, vision and innovations. Looking ahead, AFRL's focus on the Affordable Responsive Modular Rocket (ARMR) program aims to significantly cut engine development costs and timelines. The Tactically Responsive Space Access (TRSA) initiative seeks to enable on-demand space missions akin to UAV operations. Innovations such as the Rotating Detonation Rocket Engine (RDRE) promise to revolutionize propulsion systems, enhancing payload capacities and operational flexibility. Rocket Lab's future initiatives include further development of the Neutron rocket, which is designed to support large-scale missions. The company is also emphasizing modular spacecraft solutions and plans to pursue strategic partnerships that will enhance its technological capabilities and market position. Timeline of key events. 1954, AFRL begins work on the XLR-87 engine. 1959, successful launch of the Titan ICBM. 2006, Rocket Lab is founded. 2017, Electron's inaugural launch. 2018 to 2023, continued successful missions including NASA's Capstone mission. Future initiatives, launching ARMR and TRSA programs for rapid responsive space access. Conclusion. Both AFRL and Rocket Lab exemplify the evolution of rocket technology from military applications to commercial endeavors in space. Their collaborative efforts and innovative approaches are pivotal in shaping the future of space exploration and access. Through ongoing research and development, these organizations are poised to make significant contributions to the aerospace industry, heralding a new era of exploration and innovation. Comprehensive overview of Rocket Lab's journey. 1. Historical context information 2006 to 2016. Rocket Lab was founded in 2006 with a vision to make space more accessible, particularly for small satellite operators. The company aimed to provide dedicated launch services tailored to the needs of the burgeoning small satellite market. The Electron rocket, which would become its flagship vehicle, was designed with this mission in mind. The first successful launch of the Electron rocket occurred in 2017, marking a significant milestone for Rocket Lab. The company became the first private entity to reach orbit from the Southern Hemisphere during its ADA-1 mission. This success laid the groundwork for a series of successful launches, establishing Rocket Lab as a key player in the space launch sector. 2. Technological Innovations and Achievements 2017 to 2022. Rocket Lab's innovations have primarily revolved around its Electron rocket, which features a unique design that includes 3D printed engines and an electric pump-fed propulsion system. These advancements not only reduced manufacturing costs but also enhanced the rocket's reliability and performance. In 2018, Rocket Lab secured a contract to launch NASA's Capstone mission, a precursor to the Artemis program aimed at returning humans to the Moon. This mission showcased Rocket Lab's capabilities and opened doors to partnerships with government entities, further solidifying its reputation in the industry. By 2022, Rocket Lab had successfully completed numerous missions, deploying over 200 satellites for clients across commercial, civil, and defense sectors. The company's operational efficiency was demonstrated by its ability to launch multiple missions in quick succession, setting records for rapid turnaround times. 3. Current operations and market position 2023. As of 2023, Rocket Lab has expanded its offerings beyond the Electron rocket. The development of the Neutron rocket is a significant step towards launching larger payloads and supporting more complex missions. The Neutron, designed for reusability, aims to compete with other heavy-lift launch vehicles in the market. Moreover, Rocket Lab has broadened its capabilities by providing end-to-end solutions for satellite design, manufacturing, and on-orbit operations. This integrated approach has positioned Rocket Lab as a comprehensive supplier within the space economy, catering to diverse mission profiles. 4. Future aspirations and innovations 2024 and beyond. Looking forward, Rocket Lab's future initiatives include advancing the Neutron rocket and developing modular spacecraft solutions. The company's strategic focus on partnerships and acquisitions will enhance its technological capabilities and market competitiveness. The ARMR and TRSA programs initiated by AFRL will play a crucial role in shaping responsive space access solutions. Rocket Lab is expected to leverage these advancements, positioning itself at the forefront of innovations in the aerospace industry. In summary, Rocket Lab's journey from its inception to its present-day operations showcases a remarkable evolution shaped by technological advancements, strategic partnerships, and a commitment to making space more accessible. As the company sets its sights on the future, it is poised to continue leading the charge in the ever-evolving landscape of space exploration and satellite deployment. Rocket Lab, Past, Present, and Future. Introduction. Rocket Lab has become a noteworthy player in the aerospace sector, providing comprehensive launch services and advancing spacecraft technologies. Its evolution reflects a rich history, ongoing advancements, and ambitious future initiatives. Counterintuitive aspects. 1. Transition from military to commercial. While many aerospace companies have origins tied to military endeavors, Rocket Lab's transformation from a small satellite launch provider to a broader aerospace entity challenges the conventional narrative that military technologies primarily lead to government contracts. Instead, Rocket Lab has effectively leveraged its military-based expertise to propel itself into the commercial sector. 2. Public-private partnerships (PPPs). The increasing reliance on PPPs for technological advancement is counterintuitive in a field often dominated by large governmental contracts. Rocket Lab and the AFRL have shown that collaboration with private entities can be equally beneficial, enabling rapid innovation and adaptation in the commercial space sector. 3. Pioneering small satellite launches. Rocket Lab's focus on small satellite launch services might seem narrow, yet it has become the second most frequently launched rocket in the U.S. This emphasizes a shift in the market where smaller payloads are gaining precedence over traditional larger missions, countering the belief that bigger is always better in aerospace. For reusability and cost efficiency, the assumption that reusability in rockets is primarily for large-scale missions is challenged by Rocket Lab's approach with its Electron rocket. By making smaller, more frequent launches economically viable, Rocket Lab has demonstrated that cost efficiency can be achieved even at a smaller scale, reshaping industry perceptions regarding launch economics. Past historical milestones. The Air Force Research Laboratory AFRL has a storied history in U.S. rocket propulsion technology. In 1954, the AFRL initiated the development of the XLR-87 engine, which later evolved into the LR-87 for the Titan ICBM. This marked significant advancements in missile technology as the Titan ICBM became operational by 1963. With improvements that allowed for storable propellants enhancing launch readiness. Rocket Lab was founded in 2006, focusing initially on small satellite launches using its Electron rocket. With its first launch in 2017, Rocket Lab quickly established itself by successfully deploying satellites for clients like NASA and the U.S. Department of Defense. Current operations and technologies. In the current landscape, the AFRL is focused on transitioning cutting-edge rocket technologies into commercial applications through public-private partnerships (PPPs) of programs like the Integrated Powerhead Demonstration (IPD) and Upper Stage Engine Technology (USAT) are modernizing U.S. upper stage engines and introducing advanced modeling tools. The Hydrocarbon Boost Demo (HCB) program is also striving to develop high-performance reusable rocket engines to lessen reliance on foreign technology. Rocket Lab, on the other hand, is expanding beyond small launches with the development of the Neutron rocket for larger payloads. The company operates multiple launch sites, including a new facility in Virginia, and has integrated sophisticated satellite systems into its offerings, supporting over 1,700 missions globally. Future, vision and innovations. AFRL's future initiatives include the Affordable Responsive Modular Rocket (ARMR) program, aimed at significantly reducing engine development costs and timelines. The Tactically Responsive Space Access (TRSA) initiative seeks to enable rapid on-demand space missions akin to UAV operations. Innovations such as the Rotating Detonation Rocket Engine (RDRE) could potentially revolutionize propulsion systems, enhancing payload capabilities. Rocket Lab's future plans emphasize further development of the Neutron rocket for large-scale missions and increased focus on modular spacecraft solutions. The company is also pursuing strategic acquisitions and partnerships to strengthen its market position and capabilities. Conclusion. The evolution of Rocket Lab, alongside the efforts of AFRL, illustrates the transformation of rocket technology from military applications to commercial ventures. Their collaborative and innovative approaches are poised to shape the future of space exploration and access, reflecting a shift in traditional aerospace paradigms. Through continued research and development, both organizations are set to make substantial contributions to the aerospace industry, challenging established norms and expectations. The report on Rocket Lab's past, present, and future offers a comprehensive overview of the company and its significance in the aerospace industry. However, there are several important elements and nuances that may be overlooked by many readers, which hold great significance for understanding the direction of space exploration and commercial launch services. Here are some key points that deserve more focus. 1. The role of public-private partnerships (PPPs). One of the most significant aspects of Rocket Labs and the Air Force Research Laboratory's AFRL current operations is their reliance on public-private partnerships. These collaborations enable the sharing of expertise, technology, and resources between government entities and private companies. Many readers might gloss over this detail, but it is crucial for several reasons. Innovation acceleration. PPPs foster rapid technological advancements, allowing for cutting-edge developments that may be slow to emerge in traditional government-led programs. This is particularly important in the fast-evolving space sector where staying competitive requires agility and innovation. Cost efficiency, by leveraging private sector efficiencies. These partnerships can reduce costs and development timelines significantly. The ARMR Affordable Responsive Modular Rocket program aims to cut both costs and development times, setting a new standard for space access. Market growth. These collaborations also help stimulate the commercial space industry, allowing new players to enter the market and innovate without the significant initial investment that would typically be required. This democratization of space access is vital for the future of space exploration. 2. Technological evolution and historical context. The report details Rocket Lab's evolution from the development of the Electron rocket to the upcoming Neutron rocket. However, the historical context surrounding these developments, particularly the connection to earlier military projects like the Titan ICBM, is often overlooked. Understanding this history is significant for several reasons. Lessons learned. The technological advancements and failures from past military programs inform current practices in aerospace engineering, particularly regarding propulsion systems. The transition from military to commercial applications illustrates how historical military research and development can give rise to modern commercial technologies. Strategic importance. The historical emphasis on national security and rocket technology has led to innovations that now support commercial ventures. This dual-use aspect of technology is often underrepresented but is critical in understanding the strategic importance of aerospace developments. 3. Future innovations. Rotating detonation rocket engines (RDRE). The mention of the rotating detonation rocket engine (RDRE) as a potential game-changer in propulsion technology is significant, yet many readers may not grasp its full implications. The RDRE's novel approach to combustion can lead to increased efficiency. RDREs promise to enhance the efficiency of rocket engines, potentially allowing for more payload capacity or reduced fuel consumption. This efficiency could transform the economics of launching payloads into space, making it more accessible for various applications. Revolutionizing design. The ability to harness detonation-based combustion could lead to entirely new designs for rockets, simplifying structures and reducing weight. This could be particularly beneficial for missions requiring heavy payloads or innovative spacecraft designs. Strategic military applications. Given its military origins, advancements in engine technology like the RDRE not only serve commercial purposes but also have strategic military implications, enabling rapid deployment capabilities. 4. Expansion to larger payloads with Neutron rocket. Rocket Lab's development of the Neutron rocket marks a significant shift in its operational focus, aiming to accommodate larger payloads and more complex missions. This expansion carries multiple layers of significance. Market demand. As satellite constellations grow and larger missions become more common, the demand for rockets that can handle bigger payloads is increasing. Rocket Lab's response to this trend could position it favorably against competitors. Diversification of services. By moving beyond small satellite launches, Rocket Lab is not only expanding its market but is also diversifying its risk. This strategic move can help stabilize the company against fluctuations in demand for smaller launch vehicles. Impact on space infrastructure. The Neutron rocket's capabilities could facilitate the establishment of critical space infrastructure, including satellite networks for global internet coverage, Earth observation, and deep space exploration missions, thereby shaping the future of space operations. 5. Integration of spacecraft technologies. Rocket Lab's efforts to provide end-to-end solutions, including spacecraft design and satellite components, are noteworthy. Many may overlook the significance of this integrated approach to space operations. Streamlined operations. By offering both launch services and spacecraft solutions, Rocket Lab streamlines the logistics and coordination required for space missions. This can significantly reduce the time and complexity involved in getting payloads to orbit. Innovation across the value chain. The integration of different technologies, from propulsion to satellite components, encourages innovation throughout the entire value chain of space missions, fostering a more robust ecosystem. Increased customer base. This holistic offering attracts a wider range of clients from government agencies to private enterprises, thereby broadening Rocket Lab's market engagement and revenue streams. Conclusion. In summary, the report on Rocket Lab's past, present, and future provides valuable insights into the company's trajectory and its role in the aerospace industry. However, the significance of public-private partnerships, the historical context of technological developments, the potential of innovative propulsion systems like RDRE, the strategic implications of expanding to larger payloads with the Neutron rocket, and the integration of spacecraft technologies are critical themes that deserve closer examination. These elements not only highlight Rocket Lab's innovative approaches but also underscore the broader implications for the future of space exploration and access. Understanding these nuances can provide a deeper appreciation of how companies like Rocket Lab are shaping the landscape of the aerospace industry. 1. Historical milestones and technological evolution. The past of Rocket Lab is rooted in significant advancements in aerospace technology, particularly through the contributions of the Air Force Research Laboratory (AFRL). The development of pivotal engines like the LR-87 for the Titan ICBM laid the groundwork for modern rocketry. Rocket Lab's inception in 2006 marked a shift towards commercial space endeavors with a focus on small satellite launches using the Electron rocket. Analyzing these historical milestones reveals the foundational technologies that shaped Rocket Lab's current capabilities and highlights the transition from military to commercial applications in the aerospace sector. 2. Current operations and expanding capabilities. Rocket Lab's present operations showcase a strategic expansion beyond small satellite launches. The development of the Neutron rocket aims to address larger payload capacities in complex missions, indicating a proactive approach to evolving market demands. Additionally, the integration of advanced satellite systems and multiple launch sites enhances operational flexibility. Analyzing Rocket Lab's current technological advancements and operational strategies reveals insights into how the company is positioning itself within the competitive landscape of the aerospace industry. 3. Innovative future vision. Rocket Lab's future initiatives, particularly the development of the Affordable Responsive Modular Rocket (ARMR) and Tactically Responsive Space Access (TRSA), reflect a commitment to revolutionizing space access. These programs aim to reduce development costs and timelines, significantly fostering a more responsive and adaptable space launch ecosystem. The exploration of cutting-edge propulsion technologies such as the Rotating Detonation Rocket Engine (RDRE) indicates a forward-thinking mindset that prioritizes innovation. A detailed examination of these future visions provides a glimpse into the potential trajectory of Rocket Lab and its contributions to the broader aerospace industry. 4. Public-private partnerships and industry collaboration. The role of public-private partnerships (PPPs) in facilitating technological advancements and transitioning military technologies into commercial applications is crucial. Rocket Lab's collaboration with AFRL and other industry players underscores the importance of these partnerships in enhancing capabilities and driving innovation. Analyzing the impact of PPPs on Rocket Lab's growth and operational efficiency reveals how collaborative efforts can accelerate technological progress and create a more integrated aerospace ecosystem. This point emphasizes the significance of partnerships in achieving strategic goals within the aerospace sector. 1. NASA's Apollo program. Overview. The Apollo program was a series of space missions undertaken by NASA between 1961 and 1972, aimed at landing humans on the Moon and bringing them safely back to Earth. The program culminated in the historic Apollo 11 mission in July 1969, which saw astronauts Neil Armstrong and Buzz Aldrin become the first humans to set foot on the lunar surface. Historical significance. The Apollo program marked a significant achievement in human space exploration and technology, showcasing advancements in rocketry and spacecraft design. It involved multiple launches, extensive testing, and collaboration among various aerospace companies and government entities, much like Rocket Lab's focus on partnerships and commercial space endeavors. Future impact. The technologies developed during the Apollo program laid the groundwork for future space missions and advancements in aerospace engineering, influencing subsequent programs such as the Space Shuttle and Mars exploration missions. 2. SpaceX's Falcon 1 and Falcon 9. Overview. SpaceX, founded in 2002 by Elon Musk, developed the Falcon 1 as its first orbital rocket, achieving its first successful launch in 2008. The Falcon 9, introduced in 2010, became a workhorse for commercial satellite launches and resupply missions to the International Space Station (ISS). Historical significance. SpaceX's innovations such as reusable rocket technology and cost-efficient launch services revolutionized the aerospace industry, similar to Rocket Lab's approach with its Electron rocket and the upcoming Neutron rocket. SpaceX's success demonstrated the viability of private sector space launches, paving the way for new players in the industry. Future impact. SpaceX continues to expand its capabilities with the Starship program, aiming for missions to Mars and beyond, influencing future space exploration strategies and commercial opportunities. 3. The European Space Agency's Ariane program. Overview. The Ariane program, initiated in the 1970s, was developed by the European Space Agency (ESA) to provide independent access to space for Europe. The Ariane 5, the latest version, has been a reliable launch vehicle for satellites and scientific missions since its first flight in 1996. Historical significance. The program exemplifies international collaboration in aerospace with contributions from multiple European countries and companies. Its development and operational success highlight the importance of public-private partnerships akin to Rocket Lab's collaborations with various entities to enhance launch capabilities. Future impact. The Ariane program continues to evolve with the development of the Ariane 6, aimed at maintaining competitiveness in the global launch market and addressing the increasing demand for satellite launches, reflecting the ongoing evolution in space launch services. Future outlook for Rocket Lab. As Rocket Lab advances into the next decade, several transformative trends and predictions can be anticipated based on its current trajectory, technological innovations, and market dynamics. Here's a look at what the future may hold for this pioneering aerospace company. 1. Expanding launch capabilities. Rocket Lab's development of the Neutron rocket signifies a strategic shift toward larger payloads and more complex missions. Expected to debut in the near future, Neutron aims to serve the burgeoning satellite constellation market, which is projected to grow significantly due to increasing demands for global connectivity and data services. Its reusable design will likely position Rocket Lab at the forefront of sustainable space operations, reducing costs and environmental impact. 2. Increased market share in satellite launches. With more than 200 satellites deployed to date and a reputation for reliability, Rocket Lab is poised to capture a larger share of the small to medium satellite launch market. As governmental and private entities ramp up satellite deployments, especially in Earth observation communications and scientific research, Rocket Lab's efficient launch services will become increasingly attractive. The company's ability to provide tailored, responsive launch options will further enhance its competitive edge. 3. Public-private partnerships. The collaboration between Rocket Lab and entities like the Air Force Research Laboratory (AFRL) signals a continued trend of public-private partnerships. These alliances will likely facilitate the development of advanced technologies such as the rotating detonation rocket engine (RDRE), which could revolutionize propulsion systems. This synergy will enable Rocket Lab to leverage governmental resources, expertise, and funding, accelerating innovation cycles and expanding its operational capabilities. 4. Modular spacecraft solutions. As Rocket Lab focuses on modular spacecraft solutions, the company is expected to streamline mission profiles and enhance its offerings by providing customizable spacecraft components, Rocket Lab will cater to a diverse clientele, from academic institutions to commercial enterprises, enabling them to conduct a wide array of missions with greater flexibility and lower costs. This modular approach is likely to become a standard in the space industry, promoting efficiency and innovation. 5. Technological innovations. Technological advancements will continue to be a cornerstone of Rocket Lab's strategy. The ongoing development of the Affordable Responsive Modular Rocket ARMR program aims to drastically reduce engine development timelines and costs. This program, along with innovations in propulsion and satellite technology, will drive Rocket Lab to remain competitive and relevant in a rapidly evolving market. Moreover, as the aerospace industry increasingly embraces artificial intelligence and machine learning, Rocket Lab may incorporate these technologies into mission planning and operations, enhancing performance and reliability. 6. Global launch network expansion. Rocket Lab is likely to expand its global launch network, establishing additional launch sites to cater to international clients and optimize mission logistics. This expansion will facilitate faster turnaround times and enhance access to space for emerging markets. By positioning itself in strategic locations worldwide, Rocket Lab can capitalize on the growing demand for responsive space access. 7. Focus on sustainability. As the space industry faces scrutiny over its environmental impact, Rocket Lab will likely prioritize sustainable practices. This could include developing more eco-friendly propulsion systems utilizing renewable energy sources at launch facilities and implementing recycling initiatives for rocket components. By positioning itself as a leader in sustainability, Rocket Lab can attract environmentally conscious clients and stakeholders. 8. Enhanced collaboration with defense entities. Given the increasing importance of space and national security, Rocket Lab is expected to strengthen its collaboration with defense agencies. The Tactically Responsive Space Access (TRSA) initiative exemplifies this trend, aiming to provide on-demand satellite launch capabilities. As geopolitical tensions rise, the demand for rapid response capabilities in space will likely surge, positioning Rocket Lab as a key player in the defense sector. 9. Diversification of revenue streams. Rocket Lab's future may also involve diversifying its revenue streams beyond launch services. With its expertise in satellite technology and space systems, the company could expand into data services, satellite operations, and even space tourism. This diversification will not only mitigate risks associated with market fluctuations but also establish Rocket Lab as a comprehensive space solutions provider. 10. Market adaptability. Finally, Rocket Lab's ability to adapt to changing market conditions will be critical for its long-term success. The aerospace industry is characterized by rapid advancements and shifting consumer demands. By remaining agile and responsive to emerging trends such as the rise of megaconstellations and the increasing importance of space for telecommunications, Rocket Lab can maintain its competitive advantage and continue to thrive in the dynamic landscape of space exploration. Conclusion. Rocket Lab's future is poised for innovation and growth, driven by its commitment to technological advancement, partnerships, and sustainability. As it navigates the evolving landscape of the aerospace industry, Rocket Lab will likely emerge as a key player in the global space economy, shaping the future of access to and utilization of space. Through strategic initiatives and ongoing collaboration, the company is set to redefine what is possible in space exploration and satellite deployment, unlocking new opportunities for humanity's journey beyond Earth.